Okay, so welcome back again, and this is Chipmaster. So in this video, I will be working on a MacBook, right? And this MacBook, I got it as is from the tech. These are the screws, and he said that it's not turning on. So I will see if I can repair it. This part is a bit tight. Oh, so you put the screws inside of the bag and using the back screws. These are just the back screws. Alright, so let's get over to the overhead camera and see if we can fix this. Okay, so I'm gonna plug in the charger now. Alright. And this is I forgot the model. It's a A2289. Alright, so it's an A2289. And this is a T2 model. Alright, so let me plug in the charger. Alright, so I get 5 volts. It's boosting to 19 volts. As you can see. Alright, so it's boosting to 18 volts there. Oh, it's now 19 volts, 18 volts, and I get current. The screen is on. As you can see, I have the touch bar icons there, but I'm not seeing anything on the screen. Could it be a flex gate problem? Let me see if it's a flex gate issue. Normally, if it's a flex gate, if you tilt the screen, like if you half open the screen or just barely open the screen a bit away from the palm rest here, then you'll see the display. When you open it all the way, the backlight will be gone because of that flex ribbon that is torn after a period of time of opening and closing the laptop. Then it will tear that flex ribbon, so we call it the flex gate. So I get caps lock, as you can see. I get caps lock, but I'm not seeing anything on the screen. I'm trying to see if I can see an image, but I can't see a backlight image. An image to say that it's a backlight issue, why we're not getting anything on the screen. Alright, so I'm just going to take it apart. Alright, the screen is connected. Screen is connected. Let me remove the screen. All right. Oh, let me remove the battery. Okay. Bring this flex. So I'm not getting an internal display then. Oh, I see some liquid here. Doesn't look right. It seems like we have a liquid spill here, as you can see. Right here. This area here is liquid spill, and this is the backlight control capacitors. These are the boost capacitors for the backlight. But I was looking on the screen and I didn't see any image. Let me take another look again and see if I'm seeing any image on the screen, so I can confirm it's a backlight issue. Let me connect back the flex for the screen. All right, that's connected, and see if I can see any picture. And I can't see anything to say that it's a backlight. Let me just clean here. See where the Apple logo would sit. Okay, so I'm just cleaning right in the center of the screen here, so I can see that Apple logo, if there's any coming. Yes, there's the Apple logo, as you can see. If I don't know if you can see it, and I hear the chime. There's the Apple logo there, as you can see. The Apple logo is right there. There's the Apple logo right there. So it's a backlight issue there, as you can see. There's the Apple logo. I think you can see it. Ah, it's gone there. Yes, so it's a backlight issue, as you can see. All right, so let me check how much voltage is coming today. Yeah, straight. Oh, this pivot here. All right, so first I need to check on the backlight circuit here. So I'm going to plug in the charger. So I'm going to check out these capacitors to see the voltages. Oops. Yeah, right, I hear the chime. And there's no voltage there. There's no voltage there, as you can see. Right, I should be getting about 40 volts here. Right, 40 volts should be here, or 12 volts. But I'm not getting any voltage at all. Right, no voltage there. Let me check the resistance. Or we can call it the impedance. I think this is a bit bright. Anyway. And that's too low. I'm getting 21. I should be getting infinite here. right? I should get in over close to infinite. So this is a problem. So maybe one of these capacitors are cracked, right? Are leaking. So this is 21. It should be higher than this, right? I should get close to infinite on the reading on the multimeter. As you can see, I'm getting 22. So that's a problem. So I'm going to take apart the laptop. Let's continue the disassemble. The tech told me that it's not turning on, but he was giving me the wrong information. It's actually no backlight. It's a no backlight issue. These ribbons are very delicate, easily torn if not handled properly, because it's held down by a adhesive, and many techs normally tear them, damage that fingerprint for the fingerprint. And if you change the fingerprint won't work again. Let me this laptop has never been disassembled before because the fan connectors are intact and that adhesive has not been removed. So this laptop has never been taken apart before. Spacer there was removed now. Okay, so let's head under to the microscope. Okay, so as you can see, we have some liquid intake here, and it's very thick. Seems like coffee to me, or some form of tea-like substance. So most likely, maybe this cap is the problem. Yes, it is. It's cracked. It's cracked. I'm seeing pieces of it while I'm scraping off the liquid. Right, this cap is surely cracked. This one here. Right, this cap. Yeah, this one. It's cracked. Alright, so let me get the soldering irons. Right, as you can see, the crack right here on the edge right here. That part is cracked right there. Right, as you can see, there's a crack. Alright, so here you can see that right here is cracked right here. So just use the soldering hot here. There we go. Alright, let me measure the resistance. Should goes to infinite. Excellent. So I'm getting 960. It should increase. There we go. Right, so we are there now. So 1.0. So that's close to infinite, and that's the correct reading I should be getting. Right, before it was only 22. And that impedance to ground there. And it's now restored. Right, so I'll now put a new cap. I'll now put a new capacitor there now. Let me check the other side of the board as I'm checking now. All good and clean. Nice. Alright, so the new cap is installed. This is the backlight control IC. Alright, this is the backlight control chip. Right, to boost the voltage to 40 volts. Between 35 to 40 volts there. And that's done through the help of this boost capacitor here. The boost diode, sorry. This is the boost diode, and these are your boost capacitors. These are the difference in the sizes, as you can see the color and the sizes, as they are larger than all the other capacitors on the board. So these capacitors are able to withstand high voltage, so they are boost capacitor. And how a boost capacitor and how a boost circuit work in terms of, for this, it's a PWM, right? So it's a PWM, which stands for pulse width modulation, and that is used to control the brightness of the backlight through the keyboard. So it is adjustable. So that is why it is used in a boost diode, right? So in the diode, this diode has voltage on both sides. With the help of a capacitor in series to ground, it will increase the voltage by 12 volts or 10 volts depending on its input voltage, which is the first initiated voltage which is coming from the circuit or the board, right? So this voltage is going to the diode. When the diode gets that voltage, the PWM chip will ramp the duty cycle. So the faster the duty cycle, the larger the voltage, right? And the higher the frequency. So this is how our backlight circuit works, right? And as you can see, we also have a boost coil, which is here. So this boost coil is used to stabilize and to store that electric energy into a magnetic field. So the inductor is used to boost. As you can see, we have another diode here. So we have a diode on the front end and we have a diode at the back end of the coil. So this is a typical boost circuit, and this is a boost inductor, and these are boost capacitors. All right, so this is a boost inductor. So you can also, I will demonstrate with oscilloscope after repairing to show you the working principle of this backlight circuit and how it is developed. All right, so I'm just cleaning that solder paste there, which is very dangerous. It's conductive. So my table is clear. All right, so let me clean my table. All right, so my table is now cleaned. All right, so I have the new capacitors here, as you can see. So I'm just going to take out one. All right, and these are 1206 capacitors. All right, these are the size. All right, so it's 12 millimeters long and 6 millimeters wide, right? So that's why it's called a 1206 capacitor. So I'm just going to add some flux before. Alright, so I'm now checking the resistance. Right, it's hot, so it will increase slowly. Let's scrape in that extra residue there. It's a bit hard and dried. All right, so let me check again. 977, that's excellent. And that's what we want. And it's slowly increasing, as you can see. And that's the correct resistance or impedance. Perfect. Now it's 1.0 and it's almost infinite. So this is the correct reading. When the screen is connected on this line, then the resistance will change. Right? The resistance will change when it will decrease when the screen is connected to the line, right? So I'm gonna get a testing screen now. I'm gonna get a testing screen and I'm going to demonstrate testing the backlight circuit and the working principle of the backlight circuit. Okay, so I'll head over to the overhead camera. All right, this is my testing screen. And the flex ribbon here that I use to test, which is giving me that extra length so I can test screen display issues or backlight issues like this one I'm doing now. Sorry. Oh. I'll just press it on the screen. The backlight will be there anyway. Alright, so this is the assembly. So this is the flex, original flex coming from the board. And this is the test flex, which is going to connect to the LCD. Alright, so I'm going to give power. Oh, so I need a connector. I need a DC jack. Type C port here. This one is a bit. Okay, so I'm going to connect the power and I should be getting image here and see how much voltage we get here. Alright, so it's booting up, so this voltage won't appear right away, so we have to wait until the graphics card. Oh, there we have backlight. I know we have 46 volts. As you can see, there's an up logo, and I have 45 volts there, as you can see. Right, it shuts down, it's starting up back again. Alright, there we go. 3.3. When the backlight is there, we should get. Alright, it's turning off and off because the Intel is that Intel circuit. So it will using the RTC reset and the SRTC reset. I'll turn it on. Let's try again. Alright, so it's turning on. As you can see, I'm getting 46 volts, 45 volts there, call it 46 volts. Alright, let me see what's causing it not to stay on. Alright, so there we go. So that's the backlight there. So that's how the backlight circuit is produced. Alright. So now I'm going to go to the oscilloscope. It's too bright. Alright, so I'm going to do a waveform test here. Alright, so this is the boost diode. So this part of the diode should have waveform, which is controlled by the MOSFET that is going to switch. Oops. Alright, so I'm setting up the trigger levels and stuff. That's going to be 960 millivolts, 2 volts per division, and 500 microseconds there. Sorry, it should be 10 volts. And the trigger level is also going to be 6 volts. Alright, so I'm going to give power. Let's see what comes up on the screen on the oscilloscope. Alright, I haven't got anything. Let me check. Okay, so yes, so let me check again. Check on this side because there's another diode here on the coil, so I was checking on the wrong side, I believe, yes, because the boost coil is on this side, so this is the boost diode. So I'm checking the anode. Yes, this is the anode side, so I will give power now. Alright, so this is pulse width modulation, and we should get some waveform on the oscilloscope. There we go. So as you can see, I'm getting waves, and this is 20 volts per division, so that's 20, 40, 45 volts. So 20, 40, 45 volts right there, as you can see, and this is a very dense waveform, as you can see. Right? So as you can see, the pulse width modulation circuit is working, and this is a typical PWM circuit, and this is used to drive the backlight power supply to 45 volts, right? And this is the process. So as you can see, we have 20 volts per division, so that's 20, 40, 45 volts that we measured on the multimeter. All right, so that's basically how it was. That's how the backlight circuit is. So Apple uses their backlight circuit on the board, right? While ordinary computers have their backlight circuit on the screen itself, right? So this is why I normally use the screens on the ordinary computer to bypass the Apple circuit. So it is more stable and more efficient using that method, where you have to wire in the backlight power supply there for the backlight from a ordinary screen backlight, right? I think I have a sample picture here on my phone. Let me see if I can get it on the computer. Okay, so as you can see here, okay, so here is the circuit. So it was took it from my phone. All right, so this is a typical backlight circuit from an ordinary screen, as you can see, and this is how I wired into the board. So I use the scissors and cut it out, the backlight circuit on the ordinary computer screen, right? Ordinary laptop screen. Cut the backlight circuit out and then wired into the circuit here. As you can see, we have ground, we have power supply, and we have backlight output, and we have backlight enable, and we have backlight feedback, right? If you want to learn how to do this, you have to contact me personally, and I charge a fee, and we will discuss that during that process. So this is the backlight circuit for this is a A1466, right? So I couldn't repair the backlight circuit because it was looking damaged so badly, right? So as you can see here, I removed the boost capacitor, I removed the boost in the diode here. Here is the boost coil and the boost capacitors here, which is sending that 35 volts to the screen to power the backlight LED, as you can see. So this is how I do it, and I use an ordinary laptop screen because the backlight circuit is already on the screen of the ordinary board. On the Apple MacBook, the backlight circuit is on the board, right? So that's the difference between the Apple and a regular PC or Windows PC computer system, right? And this is how it is designed. So I just cut out the backlight circuit there, wired it in myself, and configure it so that it can work. All right. That's how I did it. So I'm going to put this together now. And see what I get. So I'm going to pause the video because of time. So I will get back to you after assembling the machine here. Okay, so I'm at the last steps. Alright, so alright, so everything is intact. Alright, so connect the battery. Connect the battery here. Alright, so there we go. This is the battery data. Alright, so just making sure that everything is intact before covering it up. It's there, screen is there, all is intact. Okay, so that was a good one. Alright, let's open the lid. If it's on, it's not on. Alright, it's on. Alright, so we have backlight and the screen is okay. And it's loading. Progress bar is there. Alright, so there we have it. So I hope you learned something. I hope you enjoyed the video. And this is a basic backlight repair as usual. So I have a lot of work today. I'll be working today in the office. Other technicians doesn't work here on a weekend, so I'll have to do some of the work by myself, by disassembling and assembling. So I hope, as I said again, I hope you enjoyed the video, and I will definitely repair something for you again in the next video. Alright, bye.